Welcome back. This is Ink, and in today's problem, we want to find the base impedance and the base current given the following base of 25 kilowatt and 2.4 volts. Well, 2.4 kilovolts or just 1400 volts. So, in our previous video, we went over our equation and let's just use R. So, the ohmic value, or let's just say the per unit value of a resistor is equal to the ohmic value divided by some arbitrary value we're going to call the base. So the base value, which we compare the ohmic value to, and that's how we get the per unit value. So basically, this is just the equation we're going to use. So in order to find the base impedance and the base current, we can go back to our Ohm's law. We know V is equal to I times R, and we know power is equal to V times I. As you can see, it's just some simple manipulation. So to get the current, we use our power equation because we already have power and voltage. And in order to get our I, we divide our power by V, and this will be in base. That is our current I. So to get our impedance, we know that Z is equal to V divided by I. And when we input our I, we then get V squared divided by P. And that is in base. So therefore, IB is equal to 2005. Well, not 2,500, but 25,000 divided by our 2,400. And that will give us 10.4 amperes for our base current. And this is equal to, after we calculate everything, 230.4 ohms. That is in base. Well, that was a quick one. So let's do another one. So here is another problem. So we just went over that the per unit value is equal to the ohmic value of the resistor divided by some base that we want to compare the ohmic value to. So in this problem, we see that a resistor has a per unit value, and we see we have a base power and a base voltage. So the problem asks to calculate the ohmic value of the resistor. So we can then go ahead and reorganize this. So we can get the ohmic value is equal to the per unit value multiplied by the base. We need the base because we already have the per unit value. So based on our previous equation, if we go back, before we go back though, we have voltage and power, and we know that our impedance came from that equation. So therefore, we can then go ahead and say that our ohmic value is equal to the per unit value multiplied by V squared all over P. And that is in base. So therefore, that is 5.3, and that is by multiplied by 6 to 2. So therefore, the value of our resistor is 3.3 kiloohms. This this Ohmic sign or the ohm sign is it's hard for me to draw. If I draw it slowly, it might be a little bit better, but I'm not gonna spend time drawing that. So here our ohmic value for our resistor is equal to 3.3 K. So if you think about this, if we can just do a little bit more, or we can just save that problem. We can do this problem, but let's say, all right, let's start this problem. We're not going to finish it. We're going to finish it in the next video. So let's start this problem. So using resistor A as a base, or you know what? Let's just do this problem. So these are 3 resistor ratings, right? And we want to use resistor A as a base. So this is our base. So we have a base resistance and we have a base power. Let's just write that down. So we're just going to call it resistor A. But if we say resistor A, so let's just say RB is equal to RA, which is equal to 100 ohms. Then let's call our base power just PB as equal to PRB, which is equal to 24 watts. So now let's look at the problem using resistor A as a base. Determining the per unit values of the resistance, power, and voltage rating of resistors A and B. So we want the per unit. So we need the per unit values of the resistance, power, and voltage. So we need R per unit. So we need R for per unit. We need R in per unit. We need power in per unit, and we need voltage in per unit. So if we're going to find P, power, voltage, VRE, and when you want to represent it by, and R, we're going to need voltage because we already know that based on our equation from here, voltage is important. So if we go ahead, we can calculate our voltage. Okay, so we need the base voltage. Basically, that's what I'm saying. So we have the base. Let's see if I can get my laser pen. So we have the base resistance and we have the base power. Let's get the base voltage. So our base voltage in this case would be equal to, so let's see. P is equal to V squared divided by R. Correct? So you can manipulate this saying that V squared is equal to P times R, and V is equal to the square root of P times R. So therefore, we can get our base voltage, by taking the square root of RB, which we have, and PB, which we already have. So, and as you can see, VB is actually for VA, so it might be confusing. So I might just write RB instead. But then it'll still be confusing. So let's just keep it at B and we'll track that. We'll make sure we track that. So we can get rid of these. So to find the per unit value of resistor B, we know that the per unit, so that would be RB. Oh, there it goes again. So R, and just let's just say that. mm, let's just use the base. Let's do this. Let's change this to E. Let's change. Let's just keep it that way. So let's go R. You know, we know that we're talking about the resistor B. So RB in per unit is going to equal to, remember we're using resistor A as a base value. So that means we're going to do B. Let's just use resistor B then. Yeah, this will make it more. And then A. So we know that A, resistor A. So that will give you the per unit value for resistor B. And then the per unit value of resistor C will be the same thing. We're going to use C divided by A. And for resistor, okay, that's it. And then we can also find the power. So that will be P. Let's just put this is just tricky. So we're dealing with resistor B at this point, right? So let's just put RB. It's kind of confusing. Let's just, yeah, we're gonna put B. Remember, this is for resistor B. This is not the same as our 24 watt. Maybe a different notation will be, subscript would be better. So that's per unit as well. This here should be per unit. So that would be 75 watt, because remember we're using the resistor B. So the base, well, not the base, the power rating for that resistor is equal to 75. So let's just use the numbers. That's probably what I should have done. 75, and that's divided by 24, because that is the base power. So let's put 24 here. And for B, let's put, I think this was ohms. Okay, so that'd be 50, and this should be 100. And then for C, per unit is equal to, C is 40, and the base power is 24. And then we can get the voltage for each of these. So the voltage for B, let's just say VB, is equal to, in our case, no, we're going to square root that. So we can just go ahead and use the resistor itself. So you go 3 times that, and you will get the value. Well, zero point 0.5 would be this case, right? So RB, the base, would be 0 0.5. Yep. So that'd be 0 0.5. And that would just basically, we know that's half. Let's put 0 0.5 multiplied by the power itself. You know what? Let's just put RB here for you per unit. Yes, because we want a per unit value, so that has to be per unit. And this the power for that. So this, let's just say this here is equal to B. This here is equal to BP. So BRBP. Let's just do it that way. So BR times BP. And this is in per unit. Sorry to get you guys confused. Okay. And this will be VC per unit, which is equal to, and C. So let's put C. CR times C. Man, isn't that interesting? CP. And that will also, this will equal to CP, and this is equal to CR. And that would just be how you would find the per unit values. So you'd find the per unit values of resistance, power, and voltage of the resistors B and C. So that's it, man. I'll see you in the next problem. Bye.